Improper fractions get their name from the fact that they're not really seen the way we expect to see fractions. We expect to see them in a certain way, and when we see an improper fraction, well, it's just not the way we're expecting it. Can you see what I mean by looking at the example? 17/4 appears to be a little bit top-heavy, doesn't it? We expect this number up here to be less than the bottom number, but it's considerably larger. That means that this fraction has some holes hiding in it, entire ones or twos or threes, and in this case we're going to try to find them. Okay, if you think about it, and the denominator tells us this, it takes 4/4 to make a whole. Well, if you have 17/4, you have way more than you need to make one whole, because 4/4 makes 1. And if you doubled that to 8/4, you'd make 2. And you can see that 17 is still quite a bit larger. So if we took another whole out of there, another 4/4, that would only be 12/4. We'd have 3 taken out so far. And we could actually go so far as to take 16/4, which would be 4 whole numbers out of that improper fraction. Well, you can see that if we did take 16/4 away to make our 4 wholes, there would be something left over. And 16 subtracted from 17 tells us that there would be 1/4 still remaining as a fraction. So we've made what's called a mixed numeral. Now, you've probably heard of mixed nuts. And with mixed nuts, we have lots of different kinds of nuts that we can choose from. And in the case of mixed numerals, we have 2 different things that we can choose from in the same value. We have a whole number and a fraction. And as you move along in math, you find that very often things are not expressed just in whole numbers or just in fractions, but a combination of the 2 called a mixed numeral. Well, we had the improper fraction 17/4, and this would be a good way of looking at it. We have 17 little quarter cups that you might use to measure out ingredients in the kitchen. If a recipe called for 17/4 cups, that means that you would have to dip into, let's say it was the flour, 17 times in order to get what you needed. So the recipe wouldn't say that. It would combine, whenever it could, 4/4 or 4 quarter cups to make 1 whole cup. And you can see we can do it again. 4 quarter cups makes a 2nd whole cup. 4 more does the same thing for a 3rd cup. And these final 4, instead of being done individually, can be taken as 1 large cup. So now we're left with 4 1/4 cups. So if we had to get 4 1/4 cups flour to put into our recipe, we could just dip in once, twice, 3, 4, and 5 times instead of doing it 17 times. Here's some improper fractions that we will change into mixed numerals, and we'll do it with the understanding of what this all means. And first of all, let's start with that denominator because it's so important. When you have the improper fraction 28/5, it's telling you that it would take 5/5 to make the whole. Well, we have way over what we need, as we talked about before. So how many 5/5 can be taken from 28/5? And that really reminds us of a division situation. So what would 28 divided by 5 be? Well, it would be 5. But 5 5s only make 25/5. So we have 28, so there'd be 3/5 left over that are not enough to make that next whole. Okay, the same situation here with a different denominator. Take 7 7ths to make a whole. If you have 39 7ths, you can once again make 5 wholes. That will take 35 7ths to do that. 39 divided by 7 is 5. But there would be 4 of these 7s left over. Not enough to make the next whole. In the case of 28 ninths, same scenario, different numbers. 28 ninths, 28 divided by 9 is 3, and that would be 27 ninths used to make 3, and 1/9 left over. Well, here's a very large improper fraction, 58/19. And seeing the way to do it is to divide the top by the bottom. In fact, this almost looks like a division problem that you might see in a book that's using this symbol for division, 58 divided by 19. So that will always remind you to use division to change an improper fraction to a mixed numeral. Well, if we do that, we're probably going to have to get out some paper and actually do a division problem. And it's a question of how many groups of 19/19 can be taken from 58/19. Or in this particular case, how many 19s can we take from 58? Well, we're going to have to do a multiplication problem, so we might want to get out our paper also and do the multiplication. But I'm guessing, based on the fact that that's pretty close to 20, and that's almost 60, and 20 times 3 is 60, that there probably are 3/19. Now, I'm not quite sure, so I'm going to do the workout. So I go over to my paper. 19 times 3, 9 times 3 is 27, and 3 times 1 plus the 2 that I carried is 50, and it's definitely going to work. So I can say that there are 3/19 that can be taken from 58 for a total of 57, and there's 1 left over. Now here's another way of writing a remainder, in which we have to do in this particular case. 1 what left over? Well, 1 out of 19. And when you can say 1 out of something, or anything out of something else, 1 out of 19 reminds us of the fraction 1/19. So there's 3 whole groups, 3 wholes that we can take from 58/19, but there will be 1/19 left over, thus forming our mixed numeral 3 and 1/19. Okay, we can reverse. We can go from mixed to improper, mixed numerals to improper fractions. And as you move along in your mastery of mathematics, you're going to have to use this skill in 5th and 6th grade. If this video is primarily to help 4th graders master the math that they need later on, well, this is an important step in being able to multiply and divide mixed numerals later on. Okay, here's a mixed numeral, 9 3/7. Well, once again, let's look at that denominator. It's reminding us that 1 whole would equal 7/7. But we have 9 here, so we're going to have 9 times more than the amount that 1 would give us. Well, 9 times 7 is 63, so 9 would give us 63/7. Okay, well that's done. These 9 whole numbers have been changed into fractional pieces, and 7ths, of course, is our denominator of choice here. We have one thing left to do. The extra 3/7 must be added on, so that now we get the total of 66/7. Notice that the denominator stayed the same all the way across, but 9 gave us this many 7ths. We added on the 3 extra 7ths, and that's the improper fraction that we made from that mixed numeral. Now, talking about doing this process in a nutshell, it just means the real fast shortcut to accomplishing this task of changing this very large mixed numeral, 14 3/8, into an improper fraction that will just be totally 8ths, all the whole numbers taken out. Well, here is the trick to it. Once again, the denominator is the key. If there's an 8 here, we know that a whole number would have 8 8ths. So if we multiply the 8 that we would have in the numerator times the whole number, we would get 112. Okay, what's this telling us? That the 8 8ths to make a whole times 14 wholes is 112 8ths. We'll worry about the eighths afterwards. This is just a shortcut. And next, we're going to have to consider the extra 3/8 that are left over. We've now changed 14 into eighths. Now we have to, of course, add on that extra 3. And once we do that, then we can write the improper fraction. That's a total of the number of eighths that 14 gave us, plus the 3 extra eighths, and of course eighths is going to automatically be the name of the fraction. It was to start off with, and it will be when we get finished.